comes up that we need him to answer.
Okay. Can you tell me his name?
Yeah, Andy, and then the last name is Monthi.
Okay, thank you. There he is.
There he is. Never mind.
Sorry, guys, am I a little late?
Hi, William.
You are now. William, how's it going?
Good, good, good. So funny enough, I'm in the Netherlands right now, so it is 1 a.m. here. So very interesting.
So what time is it there, William?
1 a.m.
1 a.m.
1 a.m. Thank you
yeah.
for doing this. I didn't realize you would be gone.
Oh no, it's okay. It's okay. I mean, in all fairness, like once we had to reschedule, it was, I mean, I was going to be in the Netherlands anyway, so it was no biggie.
Oh.
Plus, like, it's our orientation week, so we've been up super late.
Well, thank you.
Oh yeah, no worries at all. Always fun.
Hi, Gordon.
Hey guys, how's everybody?
Hey, you made it.
Yeah.
Heard you were tangling with the train.
Yeah, I got.
Terry had already agreed to shuffle the schedule around a little bit, so we'd be on a little later. But now,
I'm good.
We can go on whenever you want, Terry.
Let me ask you guys something. Chuck just texted me. Maybe would it be okay with everybody if we let William go first, since it's like 1 a.m. where he's at?
That would be fine with me, and then I could do my little home afterwards.
Will that work with everybody else?
Yeah, I think as long as you tell people up front that the information from the conference will be at the end of the recording and not at the beginning, because some people probably are dialing in just to catch that.
Okay.
Okay.
William, is that okay with you?
That's completely fine with me. I'm open to everything.
Okay, thank you.
So,
Gordon, you're okay
are you
with that,
saying
too,
we won't go until we won't do our thing until after the presentation here?
Yes, after the keynote, since it's
Oh.
1 a.m. where he's at.
So it'll be an hour before we're on.
Something like that, 45 minutes to an hour. Is that okay?
I guess it has to be.
If that's a problem for you, Gordon, I can do it myself, or...
No, that's fine.
Okay.
Not a problem. I'm just glad I got here okay.
Yeah. Me too.
When superdense neutron stars crash, the event can be felt across the cosmos. But astronomers would love to find these systems before they collide, and new simulations are guiding the way. Neutron stars pack the mass of our sun into a ball the size of a city. When two orbit each other, they'll eventually merge. That event produces ripples in spacetime, a blast of gamma rays and other light, and may leave behind a new black hole. Neutron stars have super strong magnetic fields filled with energetic particles. New simulations run on NASA Ames's Pleiades supercomputer show how these fields begin interacting long before the stars crash. As the magnetic fields intertwine, they produce a glow that steadily increases as the stars spiral closer together. These simulations map where the most energetic gamma rays produce a distinctive glow we could detect from Earth, a goal for next-generation telescopes. Simulations like these will help astronomers better understand how these fields interact and better predict the electromagnetic signals that will point to imminent neutron star collisions.
Well, hello everyone. This is Scott Roberts, and I'm joined here with Terry Mann, and we're on the 55th Astronomical League live program. And so that's kind of a milestone, Terry. What, did you think that we'd ever get to 55 of these episodes?
Yeah, as long as you're broadcasting, we are going to be here. We'll do our best to be here, and you're pretty dependable too, so yeah, I'm very grateful to be here this long and to have you do this for the Astronomical League as long as you have. So believe me, I'm very grateful.
Hardly a labor. It's a joy, really. So what's our show tonight?
All right. We're going to shift our lineup a little bit tonight because William is out of the country. And so we want to go ahead and let our keynote go first, but we will be followed with information about the NCRAL conference and about Alcon 2026. So if you would please just hang in there with us. I am going to ask David Levy to go ahead and start us off, as he usually does. And we will go to Chuck Allen after that. He would like to introduce William. So, David, how about, would you like to get us started?
Yes, thank you. Can you hear me all right?
Yes, I can.
Okay, great. I am, when I started being interested in astronomy, I actually had a strange reason for doing that, and that is that I was very shy and somewhat autistic as a child and as a teenager. So I gravitated towards areas that did not require working with other people. The night sky, searching for comets, was one of them. And I thought, well, this is an odd thing to do until I discovered Robert Frost and his wonderful, wonderful poem, The Road Not Taken. And I am honored to be able to share that with you right now. Two roads diverged in a yellow wood. I'm sorry I could not travel both and be one traveler. Long I stood and looked down one as far as I could, where it bent in the undergrowth. Then took the other as just as fair, and having perhaps the better claim, because it was grassy and wanted wear. So as for that, the passing there had warned them really about the same. Both that morning equally lay in leaves no step had trodden back. Oh, I kept the first for another day, yet knowing how way leads on to way, I doubted if I should ever come back. I should be telling you this with a song, somewhere ages and ages hence. Two roads diverged in a wood, and I took the one less traveled by, and that has made all the difference. Thank you very much, and back to you, Terry.
Thank you, David. There's so much truth to that, isn't it?
Yeah.
Just taking that road. All right. Thank you so much. We appreciate you being here tonight. And we are going to move on to Chuck Allen. He is the president of the Astronomical League. And Chuck, how about a little update? And if you don't mind, would you introduce William?
I'm going to hold the update off until afterwards also, because I think we're all anxious to hear from William. But one of the real pleasures of being a league officer and being involved with our awards program, as I have for many years, is meeting great astronomers in the making. And we have one of those with us tonight. William Gottemoller is a graduate of Menominee Falls High School, 2023. And when he was there, he formed an astronomy club that became one of the largest clubs in his school at that time. He arranged all kinds of field trips for the club to Yerkes Observatory and to the Milwaukee Astronomical Society Observatory, partnered with another high school for these field trips and joint meetings, became a SLU space ambassador, and with the MAS, the Milwaukee Astronomical Society, which is one of our founding member societies 80 years ago, he leads tours or led tours through the observatory. He became the youngest key holder to open the observatory and conduct public events there. And he went on to become the only youth to win 3 major awards from the Astronomical League in a period of 2 years. No one's ever done that. He won the Horkheimer-Smith Award for Service, the Horkheimer-Parker Award for Imaging, and the Horkheimer-Daria Award for Service, and nearly $4,000 in cash prizes as a result of his work there. He went on to Harvard University. He's the first student from his school to go to Harvard, and he is expecting his AB in astrophysics and physics in May of 2027. He's an undergraduate researcher at the Center for Astrophysics, Harvard and Smithsonian Internship Center. He's engaged in contracts to tutor students, I think at Princeton University remotely. He's an outreach assistant at Harvard College Observatory, a contributor to Sky and Telescope magazine, a course assistant at Harvard, and is president of the Harvard Undergraduate Astronomy Society. What he does in his copious spare time, I'm not sure, but that's just to give you an idea of how busy he stays. Right now, he's coming to us from the Netherlands, where he's at Leiden University, which is a study abroad program with Harvard. Leiden, of course, has produced no one famous other than Jan Oort and Christian Huygens, to name just a couple. So he's at a real major center for astrophysics for his study abroad. And I'm not going to get into all the publications and articles that he's written. Maybe he'll touch on a few of those, but it's my pleasure to introduce William Gottemoller.
Leiden produced Bart Bach as well.
I can't name them all.
Yeah.
Well, thank you guys so much for having me. And thanks, Chuck, for the wonderful introduction. I remember, I think the last time I got an introduction from Chuck was actually at the Astronomical League convention in 2022, when I was there because I had won the Horkheimer-Smith Award. And I just remember like being with my dad there, and that was probably honestly one of the most incredible experiences of my entire life. So obviously I have many reasons to be grateful for the Astronomical League, and it's a wonderful opportunity to be able to give back. So anyway, let me share my screen to you all, you guys, and hopefully let's do this, and then mind if there are technical difficulties. Okay. All right, can everyone see my screen?
Yes.
Yes.
Okay, wonderful. All right, so as I mentioned, and as Chuck wonderfully mentioned, my name is William Gottemoller. I am a junior or third year at Harvard University studying astrophysics and physics. And I am currently at Leiden University in Leiden, the Netherlands, studying astrophysics as well. Leiden University has an incredible astrophysics program. It's probably the best astronomy program in continental Europe. So I'm, of course, here because I want the opportunity to study with some of the best students and also some of the best researchers in the world in astrophysics, and of course make new connections. So of course, thank you guys so much for letting me go first. It is currently 1:13 a.m. where I am. So let's get into this. So I want to talk a little bit today about some of the new challenges to our model of the universe, because to say the least, we've had quite a few recently. But before we get into that, I'll give a little bit of a discussion about who I am. Chuck already gave a really good introduction about who I am, but I thought I'd mention a little bit further. So I got into astronomy when I was very young. I would say probably around 3 or 4. And of course, it was in a way that was very similar to a lot of people in that I looked up in the night sky and I was, let's just say, very profoundly curious as a result of it. I was curious as to why there were so many stars, why there was this band of hazy light that kind of looked like a cloud in the night sky, what all of that actually was. And before I knew what any of that was, the night sky was really the source of excitement, one of the biggest sources of excitement in my life. But one thing that was also significant was that my grandfather actually was the president of the Milwaukee Astronomical Society during the space race and the Apollo missions. So I always knew about astronomy, and I always was just really interested in it. And eventually, I got involved with the Milwaukee Astronomical Society myself. The image on the left is me next to G-Scope, which is our largest, our flagship observatory. And that was when I gave tours at the Milwaukee Astronomical Society. That's generally where I would um, be be ending our tour at. Eventually, I ended up at Harvard University. Here in the top middle is some of my friends. And I, of course, am studying astrophysics there and also doing a lot of research and a lot of other activities. Now, I got into research as a freshman, and that research has not only been a source of profound curiosity in the same way that the night sky was, but also has been um, given me many opportunities to travel. So the image on the bottom is me visiting Hawaii. We were actually observing on the Keck telescope, which if you look in the image, you'll see the second one from the left of those main observatories is the Keck telescope, which we were observing with. It's the second largest telescope in the world. And in the top right, I was able to do research in Taipei for an entire summer last summer. And that's, of course, me in Taipei. And I've also had teaching experiences. I've been able to teach astronomy to students around the world, including in China. This is me in Shanghai. And then, of course, now I am at Leiden studying astrophysics and also building some research connections. So I'll also talk a little bit about my research and outreach. So as I mentioned, I got into research in my freshman year of college, and I instantly fell in love with it. I, admittedly, coming from an amateur astronomy background, was very worried that I wouldn't like it, but I ended up falling in love with it very quickly. And I am so to give a little bit of I work on gravitational lensing, so we do a lot of applications of gravitational lensing to understand things about large scale structure and the biggest objects in the universe, and also to understand how dark energy works, how dark matter works. And I recently submitted my first ever lead author paper, which is on the top left, and we are waiting for it to be hopefully accepted. We just went through the peer review process, so we are maybe hopefully a few days away from it being accepted and you all being able to see it in in the archive, so in public. But I'm just waiting for that day. It should be soon. And I do a lot of other research as well. I've of course given talks on my research, but really, as much as I love research, the crown jewel of my life is being able to communicate the things that I've learned about the universe. So I believe that outreach is extremely important, and one of the reasons why I believe the Astronomical League's work is so important is because astronomy is a brilliant source of curiosity for everyone from the youngest to the oldest ages, not just the youngest children, but also the oldest, retirees. I've spoken at retirement homes, I've spoken at first grade elementary schools to first graders, and I've spoken to families. And one thing I always notice is astronomy is a beautiful source of not just curiosity, but also hope. And one thing about the world right now is that there are a lot of sources of hopelessness. And I always believe that astronomy can be, sometimes at least, that source of hope. So I've given a lot of talks around the world, but specifically to people in the US and specifically to elementary school students. The top pictures on the right are showing that. And then, of course, talks at places like the Milwaukee Astronomical Society. Now, to give a little bit of a debrief of my connection with the Astronomical League, this is probably, wow, it's been over 3 years now. I was at the Astronomical League convention in Albuquerque, New Mexico, and I got to see the Very Large Array and meet so many wonderful people at the Astronomical League, including Chuck, and Terry, and many other wonderful, wonderful people. And of course, Jack Schmidt, who was one of the only ever scientist to land on the moon, which is really incredible. And two of the awards that I won were related to astrophotography, and the picture on the right is one of the images that won one of the awards. This is of the Crescent Nebula in, I believe, Cygnus. All right, so let's go to this. Let's talk about some dark energy. So in April 2024, the Dark Energy Spectroscopic Instrument, which is this very interesting telescope you see on the right, located just northeast of Tucson in Arizona, discovered that dark energy is evolving, which means that our cosmological model may be incorrect. Now, what, of course, does that exactly mean? I just threw a bunch of words at all you guys, so let me unpack this for you all. So, first of all, that sounds a little bit like a crisis in cosmology. And to say the least, we've had a lot of crises in cosmology recently and in the last, I don't know, 100 years. But to say that dark energy behaves completely different tells us the universe is completely different than we thought it was. And to me, that sounds like a crisis, and we don't really know how to unpack it. But unfortunately, that's just the beginning. So recently, a lot, and I mean a lot, has happened in astronomy, even now. So a great example is on the left. There are new potential models of dark matter that are preferable, it seems, to the typical model of dark matter that we've used. This is actually a plot from a paper that was produced by some of our colleagues in Germany and in Europe, and they're showing that that one model of dark matter might actually be significantly preferable to our current, like the model that we use for everything in astronomy. We've also been debating significantly on the origin of these mysterious objects called little red dots, which are believed to be large black holes that are basically just like ionizing, or like basically like making a lot of gas around them super duper bright. And it's just a very compact, like galaxy looking object, but it's like a kind of a point source, really, really, really deep in the earliest stretches of the universe. And those are, we want to know a lot about those because they might tell us about how some of the largest black holes in the universe formed, or also they might play a significant role in the evolution of galaxies. Now, also, we may have detected some of the oldest stars in the universe. These are stars that have very little metal and are also supposed to be among the largest stars that can possibly be like created without collapsing upon themselves. So, to say the least, a lot has happened. But of course, I only have 45 minutes or so, so let's just focus on dark energy. So, to first discuss dark energy, we need to know a little bit about how the universe works. So I'm going to give you guys a basic idea of how the universe works. I'm sure you guys know a little bit already, but let's just give a bit of a refresher. So in the beginning, you guys might say, oh, Big Bang, but we don't actually know what happened. The physics of the universe kind of breaks down when you get to really, I mean, 300,000 years in all honesty, but once you get to 1 second, it's even worse. And as a result, we kind of are just extrapolating. We know that the universe, if we look back in time, the universe is contracting, and there's no point at which it was expanding, or like there's no point at which, like, if we go into the past, it's going to not continue to be contracting. So we believe that at one point, the universe began with a bang, and that is, of course, the Big Bang. Now I'm going to insert some like very interesting like GIF by Google that is obviously not very scientifically correct, but yeah, that's the Big Bang. Just a very large explosion. We don't really know exactly what happened, and that's a source of a lot of questions in cosmology right now as well. But of course, we do know, at least in the general sense, that there was a very jam-packed first fraction of a second. So in the first fraction of a second, and by a fraction, I mean a very small fraction of a second, the universe grew extremely quickly. So, I mean, insert another like inaccurate visualization of the Big Bang, of inflation, of the universe expanding really fast. But basically, in this early point in the universe, something caused the universe to expand extremely rapidly, like rapidly in a way that even now we could not comprehend. So what is actually rapid in this case? So we call this, first of all, cosmic inflation. So to get an idea of how rapid cosmic inflation was, let's imagine that the cost of eggs is like our universe. So like a dozen eggs costs $4 in like, I don't know, today. And you can imagine that this dozen eggs tripled in price at least 70 times in 1 nonillionth. That is 10 to the minus 30, or 1 followed by 30 zeros, 1 over 1 followed by 30 zeros, 1 nonillionth of a second. Now, what that actually means is that eggs before cosmic inflation, so in a fraction of a second, your egg prices went from $4 to $1 nonillion. So, as in 10 to the $30. So you can imagine that eggs already unaffordable are becoming even more unaffordable as a result of cosmic inflation. Now, of course, compared to the consumer price index, which is showing inflation from 2020, we had some bad inflation, but compared to eggflation related to cosmic inflation, that is really nothing. Now, of course, that probably is a little confusing still, so let's talk about it in terms of like a standard distance in the universe. So before cosmic inflation, the standard distance in the universe, let's define it as a proton. So I have a little proton here that is like the size of one specific part of the universe. And that's around 10 to the minus 15 meters. So 1 followed by 15 zeros. Now, after the cosmic inflation, that same separation went from the size of a proton to an entire light year. Now, an entire light year is hundreds of thousands of times, is like almost 100,000 times, or actually even more than 100,000 times, larger than the distance between Earth and the sun. So that means that the universe expanded extremely rapidly in this first like fraction of a second. And we believe that that actually is important because it predicts a lot of the things about the universe that we are seeing today, especially in what we call large-scale structure, which we're going to talk quite a lot about later. So, of course, the story continues, and we would say we know this part pretty well. So we talked about inflation, we talked about the Big Bang, we talked about inflation. Eventually, the universe became transparent, and by transparent I mean you could actually like light could pass through it, and we can actually see the first light that passed through as the cosmic microwave background. That's the afterglow light pattern around 400,000 years. And then eventually galaxies formed. This figure is now inaccurate because we have seen stars and galaxies up to 300 million years after the Big Bang now. And this says first stars were about 400 million years. So that tells us like things are changing really quickly in astronomy. And eventually the story becomes pretty simple. Galaxies, planets develop, and large-scale structure develops, and eventually the universe is getting accelerated. Its expansion is getting accelerated due to dark energy. So let me ask the question, what does the universe look like now? We learned a little bit about what the universe looked like 13.8 billion years ago when the universe began, but we want to know what the universe actually looks like now. And that is honestly a question that all of us are trying to ask. And of course, to ask that question means to peer back into the past of the universe. But let's figure out the composition and understand what the universe looks like. Okay, so there are three basic components of the universe. And I like to just separate them into three very simple categories so that we can all be on the same page. So first of all, there's normal matter. So normal matter is me, like you see my hand right here, that's normal matter. But also like everything, literally everything we know and we could see is normal matter. And by that, I mean cheese. I'm from Wisconsin, so just bear with me here. I'm from Wisconsin and I'm a Green Bay Packers fan. You will understand why I'm saying that. Cheese is normal matter. Cheese head is normal matter. The Chicago Bears, unfortunately, are also normal matter. And of course, because the Chicago Bears, unfortunately, are normal matter, Earth is normal matter. So is the Milky Way, and so is everything else that we've ever seen. All of the stars that we can see, all of the planets we can see, that's made out of normal matter. And we know how normal matter works in that it interacts with light. Now, on the other hand, there's also dark matter. And dark matter is believed to form most of the matter in the universe, but we've never detected it because it doesn't interact with light. The only way it interacts with things is by interacting gravitationally. And so this has been a big source of questions because the behavior of dark matter also informs how our cosmological models of the universe actually work. But the big component, and this is the one that's really weird, is dark energy. And you might notice that there's no picture of it. And that's because we don't even really know where to start. We don't have a model for what dark energy looks like, because in some ways we believe it's intrinsic to the universe, but at the same time, we also have no idea what it really is. And as I mentioned, we have no idea what dark energy looks like. But I'm really interested in dark energy primarily because, well, we'll see. We'll see. But it plays a much more significant role than normal and dark matter in the evolution of the universe. Now, what is the what is the current composition of the universe? And this also informs a lot of things about how the universe is evolving. So the reason I'm really concerned, not concerned, but really the reason I care so much about dark energy is that it's 71% of the universe. So most of the stuff is dark matter and dark energy, which of course we've never observed. 71% is dark energy and 24% is dark matter. Some measurements will give you different values. There are a lot of different measurements, and actually that's still an ongoing field of research, is to measure how much dark energy in the universe, how much dark matter in the universe that there is. But that does lead me to a kind of interesting result. So you guys might hear like the kind of cliche that we've only mapped 5% of the oceans. So I'm guessing we mapped like 0.0001% of the universe, first of all, but also we only know the fundamental nature of 5% of the universe. And actually, even that 5% of the universe, which is atoms, which is the normal matter, even that 5% of the universe, we don't entirely understand the nature of it. And that to me is a source of profound curiosity in that even the very basic components of our universe are things that we still do not understand at all. And one thing that is really interesting is that the composition is actually changing. So, first of all, why is this? So, to answer that question, we actually need to understand the nature of dark matter and dark energy, as at least we had thought before April 2024. So, first of all, what is dark matter? So, dark matter only interacts with gravity. That's, as I mentioned, it does not interact with light. So, we can't like point out a telescope and just say, oh, like we can point out a telescope and we'll see this dark matter because it'll clump like in all these different areas. That is not actually what happens. What we actually have to do is we have to see its gravitational effects on other things. So, for example, we use gravitational lensing, and that's how the people who had found the alternative dark matter models actually had measured that was by using gravitational lensing to detect weird things going on in these really distant galaxies. So we need to use gravity. But of course, that makes things a lot more difficult because we don't actually know what dark matter is made out of. So we're not able to detect it by using gravitational anomalies, by using its effect on gravity. However, we need to use other forms of detection, and those forms of detection have not found any dark matter yet. So that does leave the intriguing question is dark matter a thing, or are we getting our physics wrong, which is another question. But notice there are a lot of different possibilities for what dark matter is made out of. In all honesty, none of us really know what it is. But one thing that's really important about dark matter is how it evolves as the universe changes. So as the universe gets larger, which we know the universe is getting bigger, as the universe is getting bigger, the density of dark matter is decreasing. So we have the same amount of matter and the size of the universe is increasing, which means that the density, the amount of dark matter per unit volume is decreasing. Now, the best way to think of this is imagine you have like a large pitcher of lemonade. If you add water to that lemonade, as in expand the volume of this fluid, of this universe, but you keep the same amount of sweet, the same amount of lemon flavor, when you actually go and pour yourself a glass, you're not going to taste as sweet of lemonade as you would otherwise. So that's really what's happening to the density of dark matter as the universe is getting bigger. Now, dark energy is a little weird. So first of all, I'll just describe dark energy. We think that it's some sort of vacuum energy. By vacuum energy, I mean that it's intrinsic to the universe. So it is like embedded in the web of the universe. And we think that it just is there, but obviously we have a lot of questions related to that. So first of all, like, how does dark energy actually work? So as I mentioned, we don't really know how dark energy works. We think it's intrinsic to the universe, but that's kind of about it. We don't have any direct measurements of dark energy. And I will mention, like, we discovered it less than 30 years ago. But we think, and this is the only thing that's really important, we think that as the size of the universe gets bigger, so as our universe is expanding, the density of dark energy stays the exact same. So that means that the density of dark energy is constant. Now you can imagine, this is a little weird, you're expanding the size of your universe, and the amount of dark energy has to increase with that expansion of the universe to be able to compensate for like what otherwise would have been a decrease in the density of dark energy. So the best way to think about this is imagine you're just pouring more water into the lemonade. You're pouring more water into the same lemonade. You're not adding, you don't think you're adding sweetness at least. And no matter how much water you add to that lemonade, you could add 1 trillion gallons to it. The sweetness of that lemonade would stay the same. Now, I personally would really like that because back when I made lemonade stands as a kid, I would not have had to buy more of those like lemonade flavoring things. But of course, that's obviously not how the universe works, at least when it comes to lemon flavor. But it is, weirdly enough, how the universe works when it comes to dark energy. Now, that's really weird, but we can that does give us a lot of information about how the universe is evolving, and what's happening to the universe as the universe is growing. So first of all, let's look at the plot on the left. So this was around the first view of the universe. This was 380,000 years after the Big Bang. And you notice that dark matter is most of the universe, 63%. Photons are part of the universe and neutrinos, but atoms are about 12%, so much more than they are now. Now, interestingly enough, that this is like the first measurement we had of the composition of the universe, because this was like the first time that the universe was transparent, which means that light could actually travel freely. But of course, 13.8 billion years later, today, the story is flipped. You didn't even see dark energy in the left side, but now on the right side, dark energy is 70% of the universe, and dark matter and atoms are 30% between the two of them combined. So dark energy, that means that as the universe is getting bigger, the dark energy density is staying the same. However, the normal and dark matter density is decreasing. So what that means for us is that the total density of the universe in general is decreasing, but it's decreasing less as the dark energy density stays constant. So eventually, dark energy will be pretty much the entire universe, because the density of normal and dark matter will go to basically zero, but the dark energy density will stay the same. So the total density of the universe will be the dark energy density of the universe. So the universe's composition is evolving, and this tells us a lot of important things. So we need to know the composition of the universe because it can tell us how the universe evolved, how the universe evolved in the past. It can tell us how it's evolving now. And of course, this is an interesting question for all of us. It can tell us how the universe will end. So these are a bunch of really good possibilities, really possible ways the universe may end. And I will mention, with a constant dark energy density, as we think it was, or at least we thought it was, the universe would be flat and accelerating in, like, its expansion would be accelerating into eternity. So the universe would just keep growing forever and nothing would really change. So let's learn a little bit about, let's figure out what the DESI results actually mean here. So I want to give you guys a little bit of a refresher, a little bit of an idea what DESI actually is, and then we'll talk about the DESI results, which are incredibly profound. So first of all, what is DESI? So this is, as I mentioned, the dark energy spectroscopic instrument. And basically, it's a very massive survey of the northern sky from Kitt Peak, that's northeast of Tucson, I believe, in Arizona. And they basically mounted this spectrograph, which is basically which can measure like the basically light versus color or like brightness versus color for millions and millions of galaxies in the universe. And from that, they're able to catalog over 13 million galaxies to be able to understand the nature of dark energy. And interestingly enough, so this figure on the left is an image of the map that they created in their last data release, which you can see all this interesting structure. There's little voids every once in a while. You might see these little dark areas that are very large. Those are voids. And then there are also these filaments, these like really like kind of lanes that are connecting these really bright nodes. It looks kind of, in some ways, it looks kind of like the lymphatic system in like humans, is that you have like a node. In this case, a node is a galaxy cluster. And then there's all these like little, I don't know, like jutting out filaments that go connect galaxy cluster to galaxy cluster. And then there are, of course, galaxies aligned with those filaments and located along those filaments. So what is the dark energy survey, or sorry, not dark energy survey, that's another survey. What is the dark energy spectroscopic instrument, DESI, actually mapping? So how do they actually map the universe to understand dark energy? So they have 4 different galaxies that they look after, and they're basically doing that to be able to trace they're using that to trace the underlying structure of the universe. So first, they look at bright nearby galaxies. This is the Bright Cluster Survey, or the Bright Galaxy Survey, and bright galaxies would be the nearby galaxies that are super duper bright, and basically that allows us to map the nearby universe in a very like simple way, because we can get you're just mapping from one galaxy to another, and you can get the nearby underlying structure of the universe. And then also they look at luminous red galaxies. The reason they do that is because, of course, luminous red galaxies are the brightest galaxies located at a longer distance. So these are like elliptical galaxies, really large, bright galaxies, and they're easy to get measurements of distances of redshift. So we want to look at luminous red galaxies to be able to map the intrinsic structure of the universe out to further distances. And the same thing goes for emission line galaxies. So an emission line galaxy is basically a galaxy with very sharp emission lines. And we use those emission lines to actually get the distances. So the reason we go after emission line galaxies at really, really far distances, so like you're talking when the universe was a few billion years old, the reason we go after those is because we can get very accurate measurements of the distance with using the emission lines. So basically, that's what an emission line galaxy is. They're generally pretty star forming. And then, of course, quasars. Quasars are the brightest objects in the distant universe. So if we can map quasars out to 10, 15 billion light years, even more than that, we can basically, well, 10 to 12 billion light years, we can basically build a map of the distant universe as well. And as I mentioned, this is basically being used to trace the large-scale structure of the universe. So this is what the large-scale structure actually looks like. This is a simulation, but you can see these little nodes and then all the filaments, and then somewhere between those lines of filaments, there you can see these things called voids where there are no galaxies. And that's really like that large-scale structure, how the universe really formed on a very large scale. This is a simulation, interestingly enough. So how does DESI actually test dark energy? So the reason they use large-scale structure is because large-scale structures can actually map the cosmic web. The cosmic web is basically that web that we saw on the last image, which is showing you all the filaments and voids and everything. But dark energy plays a very integrated role in the expansion history of the universe, so the history of how the universe expanded, and also the growth of structure in the universe, so the growth of the cosmic web. And both the expansion history of the universe and the growth of structure in the universe have very clear imprints in the large-scale structure of the universe. So if we can measure the nature of the large-scale structure in the universe, we can get a very clear representation of how dark energy works, because we know pretty well how normal and dark matter work as like large fluids on the largest scales of the universe, but dark energy, the nature of dark energy is much less certain. So what actually did DESI find? And this is incredibly interesting to me. So we had said earlier that dark energy is constant with time. So its density is like this. It is flat. What Desi found, and this is still a very hot debate in the astrophysics community, what Desi found is that dark energy is evolving with time. So that means the density of dark energy is changing with time. So instead of being a lemonade that as you constantly add more water to it, you still like receive the exact same sweetness of the lemonade, maybe the sweetness is changing. But interestingly enough, and this is even more confusing, is how dark energy evolves with time is itself evolving with time. So dark energy's nature is changing with time. So as time goes on, the nature of dark energy is evolving as well. That is awfully confusing. And this was in one of the most groundbreaking results of the century for astrophysics, and it is still the source of daily papers trying to figure out which model is actually correct, whether it's the model we thought we had or this model. So how could dark energy actually be evolving? So I'm actually going to use an equation for this, which is pretty crazy. I do want to keep it like so that everyone can understand it, but you actually need an equation for this. So for the first time in a public talk ever, the very first time I've ever given a public talk, this will be the very first time that I use an equation in a public talk. So currently, basically this W value, so the W value that you see in this equation on the bottom left, basically what it means is it's the nature of dark energy. That's like basically how we describe it. It's how the energy density of dark energy changes as a function of how big the universe is, essentially. And we can see that there are two components to it. So there's W naught, so W subscore 0. That is the constant part. So if it was just W naught, we would have a universe that is just kind of, the dark energy is just staying constant. So the density of dark energy is staying constant. So that's what we believe right now. So the W value is about -1. So the W naught value is about -1 as well. So the dark energy density is kind of constant with time right now. But one thing, what Desi discovered was that there's also this additional parameter, WA, W sub A. And you might notice that it is sensitive to time. So that means that as time is changing, the nature of dark energy measurement is changing as well. So WA of T means that let's say we go to, I don't know, 10 billion years in the future, the W value of dark energy is going to change. And what we mean by change is eventually this W will become greater than -1. And when it becomes greater than -1, the density of dark energy as the universe gets bigger actually decreases. So that would tell us that the universe would not go to a point where dark energy is like this, but it would likely go to eventually what would be like an empty universe where dark energy just goes like this and falls to 0. And this was a very interesting result, to say the least. And it is an awfully interesting question as to whether this is indeed correct. So what does that actually mean for our universe? Like, you guys learned about this, wow, this crazy parameter is a little different. What does that actually mean? So currently we have this idea that eventually the universe is going to expand into nothing and forever, and it's just going to get larger and larger, and everything will become like all galaxies will be out of contact with one another, and then everything will just kind of die out. So we call that heat death. That was when we thought dark energy's density stayed constant with time. But what we think now that if Desi is correct, the news story might be quite a lot different. There are a lot of possibilities, but I'm just floating one out there. For the record, like they're not investigating this per se, because we still need to figure out whether dark energy is actually evolving or not. But if the Desi results are correct, then the news story might actually be something like this. And we call this the big crunch. So basically the universe right now is expanding, but eventually that expansion is going to start to decelerate. So we believed that if the dark energy's density was constant, the universe's expansion would accelerate into oblivion. But if dark energy is evolving with time, that would mean that eventually the expansion rate of the universe is going to get lower, is going to decelerate. And theoretically, it could either become static, so the universe would be the same size into oblivion, or eventually it could start to decrease in size as a result of the changing the changing nature of dark energy, and then also come into a crunch. Now, of course, I'll show you guys a very slightly inaccurate example of what a big crunch would actually look like. So this is just showing a bunch of galaxies. Eventually, because basically you can see it here. The coordinates of the universe, they're kind of blurry, but the coordinates are getting closer and closer and closer together. And that's basically compressing the universe into this much, much, much smaller place. And eventually that universe will just be compressed into a point. And that, of course, raises the question like, oh, will it bounce back? And that's actually what we call the big bounce. But we don't really know that answer yet. And I don't think we can know that answer for a very long time. So, of course, we're just focused on the dark energy results for now. And then also, as I mentioned, like there's another possibility. This also could be an expanding universe that becomes static. So, well, what I mean by that is as the density of dark energy is decreasing, there is not as much energy to basically create a larger expanding universe. And as a result, the universe begins to decelerate, and then it just kind of goes into like exponentially down into a universe that is just static and unchanging with time. Now, that's, of course, a little bit more depressing than a big crunch because, of course, to me, a big crunch seems more interesting because, of course, it means that the universe could maybe bounce back and maybe we can have another universe after this. And this is not just the end of all and everything, but that's just hopeful thinking. But of course, if dynamical dark energy, which is evolving dark energy, actually exists, then we do have a lot of new questions about the universe. So first of all of these things that I'm telling you, they actually depend a lot on the curvature of the universe. And we think that the universe might be flat right now, but we don't know for sure. Um, if the universe is closed, as in like a sphere, what would happen is the big crunch. But if the universe is flat, then we would have a static universe eventually. So I think a static universe would definitely be preferred, assuming our current models, because we do think that the universe is flat. But of course, there's a lot of sensitivity there. And then, of course, if the universe is open, which means like a hyperbola, so kind of like that's kind of hard to describe with my hands. But basically, if it was open, then the universe would just decelerate, but it would not decelerate quite as quickly. And that's one question. And then also we have all the basic questions that we still have to answer and we still don't quite understand is what about the Hubble tension? So we have this expansion rate of the universe, but and that's what we call the Hubble constant, but depending on the measurement type that we make, we actually can get different values for the expansion rate of the universe, depending on basically where we look. So we still need to figure out whether that's a problem. My personal opinion is that it might be an issue related to like biases between the two measurements. I don't think that there might not actually be a Hubble tension. That's definitely what I've heard around like with my collaborators, but there's still a lot of work to be done there. So we obviously don't know the answer to that question yet. And then, of course, the very simplest question, and I think we're always going to be at this question for a very, very long time, unless we make some miraculous discovery of dark matter and dark energy, is what is dark matter and what is dark energy? So, like, we don't really know what dark matter and dark energy are. Even if we're saying, oh, the nature is different, like the nature is different, we don't know what dark matter is made out of. We don't know what dark energy is made out of. Those are a lot of questions that we still have to answer. And if you have any interest in trying to answer those questions, especially if you're someone who's in high school or someone who's thinking about what to do in college, this is a really good opportunity. We always need people to bang at these answers, especially younger people like me and like all of you, hopefully. So just to give a brief summary of what we learned today. So the universe, as I mentioned, started with a bang and quickly experienced this massive inflation, which we used eggs to describe the level of inflation. And of course, the universe is made of normal matter, and dark energy that behave very differently in the universe. Now, we thought dark energy densities is constant and the matter density decreases with time. So we thought dark energy stayed the same. But of course, the dark energy spectroscopic instrument, which is called DESI, found that dark energy is probably becoming less dense. And that, of course, is a very curious question for us that leads to a lot of very interesting questions about how the universe may actually be changing and evolving over time. And that, of course, as I said, the theories of the universe have significantly changed. But to say the least, because this is, of course, probably the biggest debate in astronomy right now, we have, as usual, many more questions than we have answers. We have a lot of questions, but not a lot of answers yet. And that's why we need as many people as possible to be able to work on these subjects with us. And in fact, there are a lot of citizen science opportunities in astronomy that I'm sure many people in the Astronomical League know about. And these can actually help us solve some of these problems as well. So thank you guys so much. And if you have any questions or anything, of course, I don't know if there are going to be questions during this talk, but please do reach out to me. You can reach out to williamgottemoller@gmail.com. I will respond to anything, any questions that you have. Happy to have a Zoom meeting or anything to answer any questions. Thank you all so much.
Thank you, William. That was an amazing talk. Scott or anybody here, has anybody got any questions for William?
I had
Yeah.
a question. Since Desi takes like two different measurements, and how do you know that it's measuring the universe is expanding differently because the dark energy is changing, or is gravity itself behaving differently? How do you know what it's measuring?
That is a really good question. So the reason we think this is like basic, I will say this is not my main research field, but the main reason we think that we can focus on dark energy is because we understand on the very largest scales how dark matter and normal matter and light interact as like in the universe. So we like to picture the universe as basically a fluid. So you can think of like, I don't know, the universe is like, I don't know, like a soapy bucket of water. We know how the water acts. We know really, really well how the water acts in this fluid of the universe. But the soap, we don't understand quite as well. And that's why we can say, oh, well, we know what dark matter would look like if this model of, or we know what the large scale structure of the universe would look like if this model of dark energy was the model of the universe. Because we know how dark matter works, we know how normal matter works. But if, let's say, that's not what happened, we use some other model of dark energy. Now, these are, of course, questions that are still needing to be answered because I mentioned I may have briefly discussed this, but funny enough, um, dark matter may not exist. So, like theoretically, we still might not have the answer. We're just kind of going off the best things, our best judgments now. Dark matter is better at predicting things. We think we know the nature of it in the general sense. So we just kind of are hoping that our idea right now of the universe is at least correct in the fundamental sense so that we can isolate dark energy.
I had two questions. One on your formula slide. I noticed that the green line on the slide was W sub 0 minus WA sub AT. And then below you had plus. Is that because the W sub AT is a negative value?
Yeah, so let's see if I can. Oh, okay. So I will so the reason I just kind of did this as a so this is kind of a basic complexity. It wasn't a mistake, but basically, so we don't use time to like describe how dark energy is evolving. We use something called the scale factor, but that's a little more confusing, and most people don't know about the scale factor. So I just decided to keep it as time, and in that case, WA would have a positive value, but of course. We actually think WA has a negative value.
Okay.
Yeah.
The other question I had, if I might, I was wondering if you had run across some thinking with regard to the seemingly overdeveloped spirals at great distance. I had heard from at least one astronomer that they thought it might be because the early galaxies formed at a time when the stars were forming just solely from hydrogen and helium, therefore it took an enormous amount of gravity to pull them together, and they were hyperluminous. Have you heard anything along those lines?
Yeah, so I think I do that's a little bit out of my field, so it's not my exact
Sorry.
area of
Yeah.
expertise. No, no, no. I'm happy to hit at the question because it means it's good practice for me anyway. So I was at some talks last in January, and they were talking about these galaxies that were formed like 300 million years after the Big Bang. And it is interesting that a lot of them are appear to be much better developed than what we had expected. I think that it definitely probably tells us that our galaxy evolution models are different than we had expected. And we talked about this whole thing about the earliest stars in the universe because they're forming from this hydrogen and pretty much just like a big soup of primarily hydrogen, a little bit of helium. They have much more energy to be able to form. Um, but it does tell it like, I mean, one of the big questions, of course, is how does that fit into the cosmological model? Because none of our simulations, which our simulations are based on a particular model of the universe, none of those actually predict, or at least most of them do not predict the earliest galaxies at like 300 million years after the Big Bang. So it's a really, really interesting question that has, I don't think it's been solved yet, to say the least.
Thank you.
Yeah.
David, did you have a question?
Yes, I have a question and a comment. The reason that I wanted everyone to know during the introduction that Bart Bok was a graduate of Leiden University, where you are right now, William, is that as I was saying that, I had the very strong feeling that Bart Bok was sitting with me and listening to your lecture just as closely as I was. And I think that if he was, that he would be looking at the screen right now and he would be saying, William, you are in the same category as Jan Ort, me, meaning Bart Bok himself, and other great graduates at Leiden. You have a sense of the history, a sense of the Oort cloud that Jan Oort from Leiden dreamed up, a sense of Clyde Tombaugh's discovery of the voids in the universe in the mid 1930s, and all these things. And Bart would be saying, William, you're going to go places.
Thank
This
you so much.
fabulous, fabulous lecture. And thank you. And thank you, Scott, for giving me the honor of being able to hear this.
Thank you so much. That's a wonderful comment. I'm very honored.
Scott, do you have any questions on your end?
I just, I noticed that William has his own posse of followers here. So he had a lot of people watching, which is nice. Hello to all of his family and friends that are out there watching this. And you gave a great lecture, and I loved the way that you were presenting and unpacking some of the more difficult things to understand. As we get more and more advanced into understanding our universe, we are in it's very strange,
Yeah.
and it seems more strange all the time. But I was curious. You talked quite a bit about DESI, and is there a citizen science program tied to DESI
So I
that you're
will say,
aware of?
yeah, so I'm not aware of any, but I would definitely look into it. One thing I will say, and to everyone here, all of this data is publicly accessible. That's like the big thing about
Oh,
astronomy is we
well, there
make
you go.
all data publicly accessible. You can access every Hubble image. You can access every James Webb Space Telescope image via the Mikulski archive for space telescopes. You can see all the DESI data via the Lawrence Berkeley National Laboratory website.
Mm-hmm.
And all of the other data is available via a bunch of other sites. So if you have questions about accessing that data, whether to use it for astrophotography or to actually like um, do your own research with it, please reach out to me. But I will mention, I don't know personally about the DESI stuff, but I know with gravitational lensing and my field of research, we employ, not employ, but a lot of volunteer citizen scientists have
Mm-hmm.
made many of the major um, like identifying strong lenses, so identifying
Okay.
gravitational lenses. Many of those gravitational lenses we found were actually identified by citizen scientists who were basically charged to sift through all that data and look for those gravitational anomalies. And of course, with exoplanets, there are a lot of very good resources to be able to do citizen science, and supernovas as well. All of these things are very, very useful for astronomy. And that's why, to me, like, especially as someone who started with amateur astronomy, I I think it is a anyone who is doing amateur astronomy should really use this as an opportunity, because
Sure.
really astronomy is unique there. There are not many sciences in which like there is such strong collaboration between professionals and amateurs.
Yeah, there's no amateur brain scientists or brain surgeons or
Yeah.
any of those guys.
Yeah, there
Well,
are amateur
I've tried
astronomers.
it, but it
Amateur
didn't go.
heart specialists.
Yeah,
Yeah, seriously. That's probably
I've
a good
tried it,
thing,
but it
though.
didn't go well.
Okay.
Oops. Sorry.
Um,
Oh,
Yeah,
that's
all
very
right.
cool. That's very cool.
I was taken by when you showed that picture of the structure, how similar it looked like to brain tissue,
Yes.
neurons and nodes, and it looked like everything's connected, like a neural network.
Yeah, yeah. It's I mean, that definitely leads you to a lot of interesting questions, but one could say like the universe does look kind of like the inside of a brain. For sure. That is definitely a very unique observation.
Very
Thank
cool.
you. All right. If nobody else has any questions, we'll let William get offline and get some rest or study or whatever.
Yeah,
William,
thank you guys
thank
so much.
you
Yeah,
for
thank you
staying
all.
up
Yeah.
at
Thanks.
this late hour for us. We really appreciate it. You gave an amazing talk. It just was fantastic. And so clearly everybody enjoyed it. And it's a pleasure to see you again. And I can't wait to see what you do become. You are
Thank you
one of
guys so
those
much.
that I have to agree with what David said. You will be somewhere sometime, and all this studying will be worth everything you're doing. So, and we hope maybe we can get you back again next year, maybe, or
Oh yeah,
sometime soon. I'd
yeah,
really appreciate it. Thank you so much
yep,
for your time.
yep. And thank you all so much for having me. I'm so honored as always.
Good
Have
night,
a
Thank
wonderful
William.
night.
you.
Yep.
Bye. All right, we'll let William go. And here we go. Okay, we're going to get back to our regular schedule here. I think next I'd like to bring up uh, Gordon Bestine and Chris Kardos from the NCRAL region. They are actually part of the Cedar Amateur Astronomers. And they are going to talk about the NCRAL convention, the conference. And I can't wait to hear the details about it. Um, they do an amazing job when it comes to having conferences. They are amazing. So if you two would like to take it over, go right ahead. I can't wait to hear it.
Oh, very good. Thank you. I'm going to make a few quick comments, and then I'm going to turn it over to Gordon, who has a little presentation that will talk you through what we're planning here. But I was intrigued in William's talk about the emphasis he put on communicating to all age groups, even to young kids, because our conference this year is doing something that I'm not sure has been ever tried before. We're marrying the NCRAL 2026 conference with a couple of other activities that are meant for the general public and children and people of all ages, really. And so we've created this umbrella that we call the Eastern Iowa Cosmic Conference. And its main track is NCRAL 2026. But we also have a couple of other activities going on in parallel that are aimed at the general public and especially the younger kids and their educators and that sort of thing. So we're very excited to be hosting this. We're very honored to have the opportunity to do this. And we look forward to seeing as many of you as can make it to join us in May for this event. So Gordon, I'll turn it over to you and you can provide all the details when we're done. If there are any questions, we'll try to handle that. I'll also note that we've got two other team members on here. So Gordon and Kate are the co-chairs of the conference, Kate Poulter, and then Andy Monte is our web designer. And one of the things we're announcing tonight is our website is finally ready for prime time. So people will be able to go out. It's been online for a while, but we haven't had the ability for people to register and get their hotel rooms and that sort of stuff. That functionality is going live this evening and is live right now, actually. And so, again, we're excited and hope to see you here. So, Gordon, take it over, please.
Terry, if it's okay, I'm going to share my screen. If I can see it. Let's see. I don't see that I'm able to share that. Oh, there we go. So let me know if you can, can everybody see that? Okay, great.
Yes, we see it.
Proceed. I've made a very small PowerPoint presentation. Again, as Chris said, my colleague Kate Holtler is online. Please jump in, and then Chris, and then our really talented web designer Andy is on as well. So what we're going to talk very briefly about is the Eastern Iowa Cosmic Conference, and that's going to be coming up May 15th through the 17th this year. And as Chris alluded to, we're actually has three distinct events. Track one, we're calling, is the actual traditional NCRAL 2026. Track two is focused at the general public. Again, we're trying to, like Chris said, do a lot of outreach and get our name made, because we do a lot in our community, but we think that not very many people know about us and what we do for the schools, for STEAM, for STEM, for educators. But we're hoping this will really draw attention to that. Also, very fortunately, we applied for and were selected to receive a Harlow Shapley Program lecturer from their program that's sponsored by the American Astronomical League, and it's free. And so it was a very, very nice thing. And I'll talk a little bit more about that in a second. All the formal programs are on Saturday. So I'm going to talk for just a second about the track one agenda. It starts Friday evening with an informal event at our observatory, the Eastern Iowa Observatory and Learning Center, where Saturday the formal program begins. We're going to start off with the NCRAL business meeting, election of officers, and whatever Al wants or needs. Then we have our plenary sessions. Then the Saturday evening conference banquet. We'll have a keynote address, as well as astrophotography contests, the NCRAL and Astronomical League Awards. Sunday, we're having some optional tours that will include the visits, options to the Collins Aerospace Museum. For those of you not from this area, Collins Radio was is the group, the people that did all the radio communications and TV communications for the Apollo space mission, and the reason we got to see those beautiful pictures from the moon. Also in town, we have the National Czech and Slovak Museum, who has this astronomical clock called an orloj. It's the only one like it in the North America. It's modeled after the orloj in Prague, and it's very beautiful and fun to see. I think as William was talking about the very large array, right here in River City, we actually have a National Radio Astronomy Observatory site that's part of the very long-based array. And we've connected with those people, and they're going to open the site up, give us a little virtual tour, and then we'll actually, be able to go out and see the site. Then another option at the University of Iowa, where James Van Allen did his pioneering work at the Van Allen Space Physics Lab. We've got it set up. One of our members, Dr. Scott Bounds, who's a faculty there, is said that we can certainly have a tour and see that incredible facility where they're building these instruments and testing spacecraft. As I mentioned, the Eastern Iowa Observatory and Learning Center is our campus. Our organizations, the Cedar Amateur Astronomers, has been in existence since 1979. We were incorporated as a 501c3 in 81. And it all started back in 1984 with a parking lot that was made available to us by the Conservation Board. And then we had some concrete pads poured for observing stations, then subsequently a 16-foot dome in 91, and then a roll-off building. And then 2005, we had this exquisite building that is seen in the background there, where we have our classrooms and have all of our public presentations. Wonderful, wonderful campus and great people. Friday evening, we're going to have informal sessions with tours of the observatory, a catered meal, exhibit demonstrations, networking, informal talks, as well as we're going to have some fun activities, including laser pointers and drone photos and trivia and other fun contests and swap meeting. And should the weather cooperate here in Eastern Iowa, we'll have some observing. The Saturday conference venue is going to be in a beautiful convention complex in our downtown Cedar Rapids, the DoubleTree. And we've got a very, very impressive lineup of speakers set for us. As I mentioned earlier, we have been very fortunate to have a Harlow Shapley Lecture Program presenter, Dr. Ryan French from the Laboratory for Atmospheric and Space Physics in Boulder, Colorado, is going to be with us. He is going to be giving a free Shapley lecture at another ballroom in our venue, but he's going to lead off our speakers, and he is going to be talking about how to live under a star, and this is relative to his research in the areas of solar explosions. And our plan is that the speakers in the program, the plenaries, will start at the sun and then move out into the universe. So following Dr. French's talk, we have Jasper Halikas from the University of Iowa. He's going to talk on Touch the Sun because he's been very involved with the Parker Solar Probe. Then, moving a little farther out from the sun, Dr. Allison James from the University of Iowa is going to be talking about Nature's Light Show, the physics of aurora. Moving further out into our the cosmos and the universe, we'll have Charlotte Christensen from Grinnell College here in Iowa, and she's going to talk on the proper care and keeping of galaxies. Further on out, then, we're going to have Dr. Charles Curtin, who's from Iowa State University. He's going to talk about stars forming stars, facts or fictions. So really good topics. And then finally, for our keynote is an amateur, which I think is very fitting for an amateur group of astronomers and enthusiasts. Mr. Sean Walker is going to, he's an editor for Sky and Telescope magazine, and he's going to talk about the HBW, Hydrogen Alpha Sky Survey. This is something that got started back in 2016, that he and two of his other colleagues started this survey, and the HDW stand for the names of the gentlemen in the survey. And Sean is the W in the HDW survey. So very exciting. I have to say thank you to our member and colleague, Stephen Spangler. He's a professor emeritus from the University of Iowa Department of Physics and Astronomy, for his guidance and contacts in setting up this incredible lineup of speakers. I mentioned the Saturday or Sunday morning tours, the Collins Aerospace Museum, then the Orloy at the National Czech and Slovak Museum and Library, or the visit to the North Liberty VBLA site, and then finally to the Van Allen Space Physics Lab. I need to thank all of our partners that we're collaborating with, multiple organizations, multiple sources of support, and to put on a conference of this magnitude and depth and breadth. A little bit about Cedar Rapids. We're a very warm and welcoming community it's usually pretty beautiful in the spring, so we hope that holds so we can do some night sky observing. We have deep connections to astronomy and aerospace because of the relationship of many of our current and past members were from Collins Aerospace, as well as the University of Iowa Department of Physics and Astronomy, current and past faculty and educators there. Cedar Rapids tends to be a technologically advanced in our employers and having these opportunities. We have exceptional educational institutions and programs, and we are very blessed to have such a diverse array of cultural dining and fine arts things to do while people are here for the astronomy orphans and people lost by themselves. As Chris mentioned, our website is a lot more information and more detail, FAQs. So visit our website as we've been trying to get all the functionality working properly, and I think it's live. I'm sure there'll be some updates and to follow those for further updates. So again, the registration information we think is functioning well and is open. Detailed agendas and timelines are there. Our speakers and more detail on their topics, their CVs, the banquet choices you can make ahead of time, the information about the Harlow Shapley lecture program, our sponsors or donors. And if you're interested in the more about what's going on with track 2 or the Shapley lecture, please there. And of course, much more. So save the date and plan to join us at the Eastern Iowa Cosmic Conference in May here. And I'll entertain any questions, or if Chris or Kate or Andy want to add anything, please jump in.
Nothing to add, just happy to take questions.
I'd just like to make a statement. I had the privilege of speaking at the Eastern Iowa Observatory. The facility is fantastic and the people are wonderful. I can just vouch for the fact this will be a warm and wonderful experience.
Thanks for that, Chuck.
Kate, anything you want to add?
We attended one of the conferences last year, and you put on one of the most amazing conferences. I'm looking forward to, I'll be there along with Chuck, I do believe, in May. So I'm really looking forward to meeting everybody again. And your lineup sounds stellar. It really sounds great.
Incredible. Yeah.
Yes, it is.
I've used that, and I tell people, with pun intended, that it's a stellar lineup for an astronomy conference. But the one thing I will say, if you say you're going to come, please get in there and get your room early, because we've subsequently found out that the venue where we're at is almost filled to capacity. So we have a block of rooms reserve at a very reasonable conference price, but they're filling up fast. So please, if you want to get a room, we do have some resources on our website that talks about other places you can stay, and we do have an option that some other sister hotels in Cedar Rapids, but not at the venue, may be able to offer us reasonable pricing as well. But so get in go early. So
yeah,
thank you.
There are 2 or 3 hotels within walking distance. So
yeah.
Yep.
But turns out we didn't realize it at the time we picked our dates, and we picked them kind of because that was when we were going to have beautiful spring weather as well as a new moon. And so it's a weekend after Mother's Day, but it's more importantly, it's like every college in the area is having their graduations that weekend, and there's baseball tournaments and that sort of thing. So hotel availability may become a real issue. If you if you're trying to register for a room at the hotel and you can't find one there at a reasonable price, because their advertised price now to the public is like double what our reserved rooms are. If you can't find a reasonable room there or elsewhere, let us know by email, or there's both an email and a phone number at the bottom of the website. if we know there's enough demand, we can try and go out to some of these other hotels and negotiate some blocks of rooms. But of course, the problem is once we do that, we're committed to paying for them, whether they get used or not. So that's why we were a little conservative in the original number of rooms that we reserved, and why we didn't foresee the fact that we would have this crunch on hotels that weekend.
One of the other things that could happen, Steve Spangler has said that, hey, if the hotels are filled, we can't get anybody. We got a lot of room at our campus at the Eastern Iowa Observatory. Bring your sleeping bag and you can camp out under the stars. So,
All right. Well,
Kate,
thank
do you
you.
have anything? I want to give Kate a chance to jump in. She's done a lot of work on this, and
I like the camping idea. So sounds good to me.
All
Can you
right.
hear me, guys?
yep.
Yes.
We hear you. Yep.
Well,
All right.
I'm looking
Thanks.
forward to it. Thank you for the information too. We appreciate that. And if nobody else has any questions. All right. Well, thank you. Thank you both. We appreciate you being here and your time too.
Thank you. It was a great
You're
time.
very
to
welcome.
listen.
Sure. All right. Next up, Brian Simpson, the president of the Cincinnati Astronomical Society. And it will be that society that will be hosting Alcon 2026. And I'm looking forward to your update too, Brian.
Well, thanks, Terry. Can you hear me okay?
Yes.
Very good. Well, we've made a lot of progress since the December AL Live, and I'm really happy to be able to share a lot of it with you tonight. Our co-chairs, Laura and Eric, have been absolutely spectacular with their planning. I go through our Google Drive and look at the spreadsheets they put together for this, and I have no idea how anybody has that much time to put that much information together. But they're doing an absolutely tremendous job putting this together, and our whole committee, Terry Andrus, and of course Chuck Allen and Terry Mann and other people on the committee, getting our speakers and our programs all lined up for August. And let me go ahead and share my screen and I'll give you all the update, because we are also going to be sharing something with you tonight that we've kind of been holding up our sleeve a little bit. And that is going to be information about the after party. And I'll talk a little bit about that tonight as well. And let's see if I can get the deck up here. If you guys can let me know when you see that. Do we have the deck up?
Yes, we see it.
Yep.
All right, Alcon 2026, Cincinnati. Of course, we are the Cincinnati Astronomical Society, and I'm going to forego the information about our club mostly that I shared in previous sessions, just because we're going to put some information up on the website so everybody can learn a little bit more about us. But I will share just a couple things here in a second. August 12th to 15th. Can you see that has the slide advanced? I just have to make sure.
Yeah, we see it.
August 12th to 15th, we will be having this at the Marriott River Center, which is actually right across the Ohio River in Covington, Kentucky. You can see the Cincinnati skyline very beautifully from the Marriott River Center. This is a great venue. Really excited we were able to get this venue nailed down. This is really within walking distance of a lot of Cincinnati and very, very close to a lot of attractions. And that's really what we wanted. We wanted this to be about celebrating amateur astronomy, but we also wanted to give people an opportunity to come to Cincinnati and experience the city, especially because this is the first Alcon that has been in the Great Lakes region, I think, for 27 years. So it's been a minute since it's been in this area, and we hope people in this region particularly will be coming to Cincinnati for this. So Marriott River Center, here is the River Center itself. Like I said, it's a really great venue. There's the interior of the venue with the bar. I always got to put the bar front and center in the presentation. Here's the atrium, where we will be having several events in this atrium during the course of the Alcon. Here's the view out of the northern side of the building, looking out over the Ohio River towards downtown Cincinnati. This is actually fairly walkable to get to downtown Cincinnati if you want to go and do some exploring, but there's some other options for transportation as well. And there's another shot of Cincinnati with our beautiful historic Roebling Bridge, which was the precursor to the Brooklyn Bridge. And so we're going to have all of the usual things that we would have in an Alcon. We'll have our speakers, we'll have happy hours, of course. The annual Starbecue will take place, which I'll talk about in a moment. We'll have the banquet on Saturday night and the keynote, and we'll have some special events peppered throughout the Alcon. I want to talk about our speakers, and I'll start with our 3 featured speakers. And Chuck Allen, be sure to jump in on this if you have any additional information. Now, I will tell you some of the speakers, we're still working on the topics for them, so I won't really go over the topics too much. But Dr. Shane Larson, who Chuck Allen has arranged for us to have come here, professor of physics at Clarkson University, very highly recommended fellow of the American Physical Society. We're very excited to have Dr. Larson to come to Alcon 2026. We also have Pran Haizeni, who is PhD candidate in planetary astronomy at UC Santa Cruz. Of course, a lot of you probably know her. She has a very, very strong social media presence. She gets stronger almost by the month, travels a lot all over the country and all over the world, even to experience astronomy in different venues. And she's using her power of social media to really promote astronomy. So we're really, really pleased to have her coming to Cincinnati for Alcon 2026. And then, of course, our keynote speaker will be Dr. Rebecca Williams, Deputy Principal Investigator of Mars Perseverance, MassCam and MartyCams, Senior Science at the Planetary Science Institute. Highly recommended. Chuck Allen has gone on and on about what an amazing presenter she is, and we are really excited to have her to do the keynote speech, the keynote presentation on Saturday night at Alcon 2026 Cincinnati. Chuck, do you have anything to add about the featured speakers?
Well, if you have any interest in Mars at all, Dr. Williams' presentation will make you feel like you've been there. She follows the Perseverance up the mountain, really, in Sharp Crater, and it's just a phenomenal presentation in every respect. I brought her in as a speaker at my club, and after she disconnected, I got a standing ovation from my club for inviting her. That's how good she is. And the Dr. Larson spoke at Bryce Canyon and knocked it out of the park. He's a really dynamic speaker, just engages the audience directly in every aspect of the talk. And you're going to find both of them really fantastic. And Pran, of course, we all know is, if she talks about her involvement in Kosovo and developing the science center there, it's a fabulous story. So these are great speakers, all of them.
Yeah, and I think Pran's her presentation will be on a scientific topic. I think some of her studies on asteroids, but we are working with her to see if she can do a short segment on her work with the Kosovo Observatory. We really feel like it was important to give her a little bit of time to promote that. That's a really big accomplishment, and we want to pay service to her work on that. So moving on through the conference, I'll just go through the rest of these fairly quickly. Our general session speakers, we've got Scott Harrington from Sky and Telescope coming, Jericho Kuehl, who was a very bright young gentleman who did I think he did one of the lectures on AL Live in December. Really bright future for him. Young man did a fantastic lecture on citizen science. We're really excited that he's coming, and I believe he will be speaking about citizen science. And I will say citizen science is going to be a fairly well-represented topic at the Alcon this year. And then we've got Dr. Wes Ryle, who is the astronomer at the Cincinnati Observatory. The Cincinnati Observatory and CAS, we share kind of a bit of a common history, and we have a lot of common crossover members between our two groups. And so Dr. Ryle is going to be speaking at the Alcon as well. We do have John Ventry, who was the former astronomer for, I think, 25 years at the Cincinnati Observatory. He's written a couple of books, including The History of the Cincinnati Astronomical Society. He'll be giving a really wonderful kickoff presentation on our soft start on Thursday morning, which I'll talk about our structure here in just a moment. He'll be giving a presentation on how he spent almost 20 years locating and recovering the stolen primary lens of the CAS 1880 Alvin Clark refractor. And that's a really interesting and amazing story, especially the way he tells it. We'll have Dr. Nick Abel from a professor of physics from UC Claremont. We're going to have a speaker, Dusty Segredo. He is an expert in micrometeorites, both finding them and photographing them. He did our lecture at our holidays party here at CAS in December, and it's really fascinating, and I think it's going to be something people will really, really enjoy learning how to get their own micrometeorites. Really interesting lecture. So we've kind of pivoted and said, hey, we need to get him for the Alcon. So we're really happy he's coming. And then we've got this panel, Dr. Jeremy Huber, Emmy Bursk, Amy Donbar, Catherine Heil, and then the moderator, Terry Endress, of the Engaging Young Scientists panel. That will be happening, I think, on Saturday. So that is going to be a really, really interesting panel of discussion for Saturday. And then we have several members of our group, CAS, who are really leading the charge in our citizen science efforts. Jeff Rodriguez, who has been a key in reviving radio astronomy at CAS. He's been doing a lot of work on exoplanets with Matthew Garrett, who is also a exoplanet, I would call him almost an expert at doing exoplanet work with the NASA ExoWatch program. They've been submitting a lot of data. And then, of course, John Blazing, our CAS second vice president, will be giving a presentation on radio astronomy. He spearheaded our Radio Jove project at CAS over the last couple of years. So he's going to be doing a presentation on that as well. And then the conference format, I think I left a couple people off, but that's fine. We'll circle back on those in the next presentation. So the conference format is going to be as such. Thursday morning, we're going to have a soft start with John Ventry's presentation. There's going to be a brunch. And then the hard start, the actual official start of the conference is going to be at 1 o'clock on Thursday afternoon. And we've chosen to do this for a couple of reasons. One, we have so many people who are within a few hours driving. We wanted to give people time to travel in on Thursday morning without having to incur the additional cost of the Wednesday night hotel room. So that's one of the reasons why we are doing a soft start. And also because people might actually want to stay an extra day on Sunday, which I'm going to get into here in just a couple of moments. Friday, we're going to have a split day. We're going to have sessions in the morning and sessions in the evening when Dr. Larson and Pran Haizeni speak on Friday evening. But in the middle of that, in the afternoon, we're going to have what is called a exploration window, Cincinnati Explore Cincinnati window, where we will be arranging for I'm actually kind of getting ahead of myself here a little bit. I'll talk a little bit about the events here in a moment. But on Thursday night, one of our two featured events is going to be the Starbecue. This is Thursday night, August 13th. There will be food and beverage at the Cincinnati Museum Center. This is a very historic venue. This is a place to be. If you've never been to Cincinnati before, you're going to want to go to this. The Cincinnati Museum Center is one of the most heralded and historic examples of Art Deco architecture in the United States. It was converted into a museum center in the late 80s, early 90s, after nearly being demolished. I mean, I can't even fathom why anybody would consider demolishing this. It is such an amazing venue. You can see here is the gorgeous rotunda on the inside of the center. It is a favorite of people in this area, and we're really, really happy to be having the Starbecue in this historic venue. The Natural History Museum and the Armstrong Gallery are both part of this. We will be having the Starbecue in what we're calling a strolling Starbecue in those galleries. And so here's a couple pictures. There's a lot of dinosaurs and fossils and all sorts of interesting artifacts in this Natural History Museum for people to peruse while they're there. So this is the venue for the Starbecue. There's some really cool caves you can discover. You can check out mammoth skeletons, all sorts of really cool stuff in this venue. Then of the other featured event will be the banquet, keynote, and the awards ceremony on Saturday night. Of course, that is going to be Dr. Williams giving us her Mars lecture on Saturday night. So that's going to be something everybody's going to want to attend. Just to get into some of the special events that we've got planned, Wednesday night, the night before the first day of the conference. We're going to have a welcome dinner and social at Molly Malone's Irish Pub in Covington. We have reserved a space there. This is walking distance from the Marriott, so no worries about transportation or having a little too much fun that night, because you can just walk right over to the Marriott afterwards. Another special event will be Thursday morning. We're going to have a soft start brunch and presentation. I mentioned before, John Venturi will be kicking it off to talk about the mystery of the stolen lens, his nearly 20-year effort to recover the objective lens of the CAS 1880 Alvin Clark refractor. Very entertaining lecture. Another special event at 1 o'clock, we'll have the official start, the opening remarks, myself, Chuck Allen, and then we'll get right into some programming right after that at 1 p.m. Another special event I mentioned before, the Explore Cincinnati activity window. We'll have 2 planned events. One is going to be a visit to the historic Cincinnati Observatory. We will be providing transportation for that. And the other one will be a Cincinnati Underground Brewery tour. There are brewing caves in Cincinnati in the north end of our downtown area that have become a really big tourist attraction. And so we thought we would give people the option to do something a little different than the observatory, because we realize there's going to be a lot of people who are from this area who have already been to the observatory. So we're working on some other things. And we'll also have some ad hoc options that we're planning to put together, some CAS ambassadors who will take people to places around town that they might want to visit, whether it's the aquarium or the sign museum, maybe it's the Reds Hall of Fame, whatever it might be. We are going to have some ad hoc events that we will assist people with. And then there's the Cincinnati Observatory there on the left, and then the Cincinnati Brewery Cave Tour, some photos from those options. And then another special event is Saturday afternoon, August 15th. We will have a pre-banquet social hour at the Marriott River Center atrium, complimentary beer or wine from the Marriott. That'll be a nice lead into the banquet. And then we're also really encouraging people to come early and visit Cincinnati, because we have so many different things that you can do here. Our zoo is world class. Of course, we have the museum center where the Starbecue is, but you might want to take some time and explore that on your own. Of course, the Cincinnati Observatory is part of our planned event for Friday afternoon. The Findlay Market, which is one of the best markets, urban markets, Fountain Square, the Newport Aquarium, the Reds Museum. I think they're actually playing Sunday. I mentioned American Sign Museum. There's all sorts of things, and we're going to do whatever we can to help people get the most out of their trip to the city, not just visiting the to come for the Alcon, but anything else that they might want to do. Now, I've teased this before, and I'm going to go ahead and spill the beans a little bit tonight about the after party. This is something that we're doing that's a little bit different than other Alcons. Now, this is technically not part of the Alcon, but we really felt like it would be a shame to have the Alcon and have people coming from all over and not take advantage of what I'm about to share with you. We have not made any public announcements about this yet, so you guys are getting the sneak peek, and we will be making the public announcement about what I'm going to tell you here in a minute and within the next couple of weeks. Sunday, August 16th from 2 p.m. to midnight, we are going to have an after party, and that is going to include food, beverage, and a band. Dark sky observing, I always put the asterisk on there because we have to worry about the weather. And this is going to be in a remote location, and it's going to be at the Moller Observatory. Now, the Moller Observatory is a new observatory that has been built in South Central Ohio. Not a lot of people know about it because we've kind of kept it under wraps. It's not ours. It is a private observatory that has been built by local Cincinnati area businessman and lifelong amateur astronomer David Levy, and he has been kind enough to offer us a partnership with him to help him run his observatory to help us achieve our overlapping goals, which are to elevate amateur astronomy in our area and to use this facility as a means of inspiration to inspire the next generation of scientists, engineers, and astronomers. And this is a significant place to be, which is why we want to give everybody an opportunity to go there. And I will tell you that Dieter is a very generous person, and he is basically footing the bill for the entire party. So this will be of no charge to anybody who is at the Alcon to come to this party. The only thing that will incur any cost is if you need to take the transportation that we are arranging for people who might not be driving to the Alcon. So we are going to be arranging for transportation because it's about a 90-minute drive out there. So 90 minutes from Cincinnati to the Muller Observatory, which is in Adams County, Ohio, south central Ohio, in a very dark location. It's very wonderful. And I'd like to share some photos and some videos of that with you now. And this is the Muller Observatory. This is built on a hill overlooking the Ohio River, and this is a tremendously amazing facility. It's in a gorgeous location with dark skies, and we are so privileged to be partners with Gottemoller and the Muller Observatory, and we're really happy to be able to share this with people who come to Alcon. You can see just how stunningly beautiful this observatory is, and this is going to be something people are not going to want to miss, even though it will require you to stay overnight Sunday into Monday. Here is a look inside of the roll-off. There's 3 piers. There on the right is a plane wave Delta Row 350 astrograph. And then on the left is an Astrophysics 1600 mount, which currently has a Lunt 152 millimeter hydrogen alpha solar scope on it. And then in the center is the star of this build. It's actually really, I think it's one of the most amazing telescopes I've ever looked through. This is the Tech 250 10-inch refractor. This is a unbeatable refractor in terms of sharpness and views, and we're really excited to have more people to come out and look through it. It is tremendous. In the main dome, a plane wave 1 meter PW1000 reflector. This is a research grade telescope, and Gottemoller has spared no expense to make this a significant facility where we can do observing, astrophotography, and citizen science. And we're really pleased to have people to be able to come and see this for themselves. And look, just a couple little, I'm sure many aware of the high quality optics of plane wave, and they have been amazing partners with the Muller Observatory to get that. It's fantastic. So here's another quick shot of it. The Muller Observatory is a beautiful facility. It is detailed in all of the best ways possible. Dieter has spared no expense to make this a first-class facility, and we're really, really happy to be able to share this with you coming to Alcon. Here's a view from below the main observatory. This is actually an early shot. This is from September of 2024. This was actually the first CAS member event that we had out there for observing. It is a spectacular place to be. This observing platform that he has built looks out over the Ohio River. It is horizon to horizon. You can see everything. And especially to the south, there is nothing to the south of here. It is exceptionally dark. Here's the camping terrace that Dieter has built for people who want to come and camp. And if people want to do that, they can do that the night of this party. We are going to be offering overnight camping for people who want to stay overnight. Here's the observing platform again. That's looking southeast. People can bring their own telescopes. There's electrical outlets you can plug in, observe all night, photograph all night, whatever you'd like to do. And by the way, our 2 co-chairs are actually in this picture. Laura on the right there in the red shirt, and Eric, who's got the blue cap with his back turned towards the photo. I didn't realize that they were in this picture when I put it in here, but there they are. There's Gottemoller himself looking through the Tech 250. It is an absolutely stunning piece of equipment. I was actually able to see swirls and eddies on the surface of Jupiter through this telescope. There's another shot of the dome that's looking south. Of course, the moon was out that night, but it was still a stunning photograph. Here's some of our members doing some astrophotography with the Delta Row 350, observing through the Tech 250. Here is an aerial drone shot of the facility in use. One of our members' nights that we've had probably in the last 15, 16 months, we've had about 8 to 10 different member events. Of course, we fight the weather here in Ohio a little bit. Beautifully, beautifully landscaped. It is just such an amazing place to be. There's a time lapse. I took this last year from the Muller Observatory. The Milky Way is very prominent at night there. You're able to see the Lagoon Nebula naked eye easily from this location. And then, of course, we've been blessed with a lot of aurora lately. And I took the opportunity to go out there on one of the nights where it was predicted we would have aurora, and it did not disappoint. It was a tremendous night to be at the Muller Observatory. So that's the after party at the Muller Observatory, Sunday, August 16th, after the Alcon. Again, it's not officially part of the Alcon, but we are offering the party to anyone who comes to the Alcon to visit the Muller Observatory. And then, of course, sign up to be notified when registration goes live, which we are expecting to be probably within the next 10 days. We're very close, and we're putting a lot of work into getting the site tested and the ticketing system tested. But if you sign up to be notified, alcon2026.org will let you know when it's live, and you can go on and you can start signing up for all the different events. We'll have booking available at the Marriott River Center through the site as well. And that's coming, like I said, we're thinking within the next 10 days or so, as soon as we finish our testing. If you want to know more about our organization, the Cincinnati Astronomical Society, please visit cinastro.org. And I want to thank Laura Zajac and Eric Shermley. They are absolute superstars putting this together. They are going to be Alcon planning experts, although they probably would hate for me to say that out loud. But they have generated a wealth of knowledge and are really doing an amazing job getting this organized. So thanks to both of them for taking this on. It is a lot of work, and it's a Herculean effort. So we'll see you this August in Cincinnati. Anybody have any questions?
I don't think so. It's very, very complete presentation. Thank you, Brian.
I will add, I have gotten to see this observatory firsthand, and it's stunning. And there's a big facility Brian didn't show you down at the bottom of the hill, which is, I assume, where some of the party will be held. And it's an indoor facility with restrooms, and so it's just perfect for this.
Yeah, there's another structure at the bottom of the hill in the woods, and that Dieter Moller and his wife use as a sort of like a place to get away. And that was actually the reason that they bought the property. And then the genesis of the idea to build an observatory happened. But it is a very large facility, and it's actually big enough to hold, I think we've decided that we're probably going to have to cap the event at about 250. And I just assume that we probably won't have everyone coming to the Alcon going to the after party. But in the event that there is bad weather, we're still going to go through with it, because we've got, caterers lined up and all sorts of things planned. So if we have to be inside, we're not going to jinx it. It's going to be great. It'll be clear. I know that's a couple of days after the peak of the Perseids with a very, very, very thin moon. So we'll hope we can get some observing in, because it is a great place to go and do some observing. So, but yes, there's indoor restrooms. We probably have some additional restroom facilities. So yeah, all the amenities are there. And so it should be a really great place for everybody to come and visit.
I would like to add too, we've worked with Laura and Eric. They've put together such an amazing event. And Brian, you and the committee that works on this, the time, as you said, the detail that they have put into all of this, the committee, you, Laura and Eric, has been amazing. This will be an amazing event. And the Muller Observatory, the after party, will just be the icing on the cake. It is going to be amazing. So please join us. Get ready. Plan to stay that extra day. Plan to do it. You will not be disappointed. This will be amazing.
We're going to put the party in Star Party for this. We're excited to get people here and have a great time. Everything that's on the schedule is, it's 90% fleshed out, but you never know. We might, like I said, do some ad hoc things, and there's a lot of places near the hotel for some after hours revelry and so on and so forth. So we're looking forward to meeting so many people. Sign up. We'll let you know when it's ready. Like I said, it's probably going to be within about the next 10 days or so, and we'll look forward to seeing everybody here in August.
That sounds great. Thank you so much, Brian. And again, thanks to Laura, Eric, and the committee. Amazing job done. So thank you.
Thank
All
you.
right. Sure. I want to talk just for a minute about the next AL Live. The next one will be, we will skip, and it's naturally gone now. We will skip February. We had to reschedule tonight. We originally were planned for last Friday, and we had to reschedule. So what we are going to do is jump on to February. That has the wrong, no, that's got the wrong date on it. Please don't look at that. It is March 6th. February, we will not have an AL Live. It is March 6th that John Goss will be on, and he will talk about different projects and activities from the Astronomical League. So please join us March 6th. The ad will be in Carol's WhatsApp that is sent to you that will have the correct date on it. Please join us then. And until then, unless anybody has got any more comments, I'm going to turn that back over to Scott. And thank you, everybody, for joining us. Thank you to all the speakers. You have all been amazing. I'm looking forward to the NCRAL conference. Alcon's going to be great. William was just amazing. It has been just an amazing night. And thanks to David Levy, too, and Chuck. I know everybody's schedule's busy. We appreciate your time. And thank you, everybody, for watching. We couldn't do it without you. So, Scott, I'm going to turn it back over to you.
Okay. All right. Well, that was just an amazing lineup of speakers. Just really incredible, and so much excitement about things to come. So we have, I'll make a small announcement that we have the 177th Global Star Party happening February 17th. That will be at the same time as the Lunar New Year in China and most parts of Asia as well. So it's also the anniversary of one of the Voyagers, and there are several things to be focused on that particular day. So that are either astronomical or space exploration themed. We hope to see you there, and until that time, you guys keep looking up. And thank you to the Astronomical League for allowing me to present the AL Live conference or AL Live events. If you have not already, if you're watching this and you haven't joined the Astronomical League, you should join through either a club that is a league club, or to become a member at large. You can join from anywhere in the world. And so you just go to astroleague.org. There is a link in this announcement, and so you can go straight there and they'll get you all fixed up. They have so many observing programs, so many award programs. They are the world's largest federation of astronomy clubs. And so with a membership, I think greater, correct me if I'm wrong, I think it's greater than 30,000 members. Is that right?
25,000. Yeah.
25. Okay. Just stack on another 5,000. We'll have to make
We appreciate your optimism.
You'll get there. You'll get there. So anyhow, thanks a lot. Thank you, Terry. And until next time.
Thanks, Scott.
Thank you.
Thanks, everybody.